Assalamu alaikum and welcome to Cambridge Chemistry channel with sarwatAhmed. Be sure to like the video and subscribe. It really helps the channels to grow. In this video we will discuss Gibbs free energy and entropy and their the relationship of entropy with Gibbs free energy. Let's start. You know that Gibbs free energy it is the measure of a system to undergo a spontaneous change. Represented with capital G. You know that there are two types of reaction I have discussed earlier in the entropy. There are two types of reaction: chemical reaction, spontaneous and non-spontaneous. I have discussed earlier that the spontaneous reaction occurs without any influence, while non-spontaneous reaction occurs with the continuous provision of energy. So chemical reaction, spontaneous and non-spontaneous. I have discussed earlier in previous video. You know that spontaneously there are many reactions which occur without the influence of energy. For example, um, reaction of group 1 metals, reaction of group 1 metal with oxygen and water, and burning of methane gas at 25 degrees centigrade temperature in closed container. While non-spontaneous reaction occurs with provision of continuous supply of energy. For example, decomposition, reaction, C calcium carbonate decomposed to form calcium oxide, or any other decomposition reaction. So this is just the example. So next term, which is very important, standard Gibbs free energy. it is the energy change, energy when any element react with any other elements under standard conditions. Element reaction under standard conditions to form product represented with standard Gibbs free energy. And you know that delta G standard Gibbs free energy of an element is always equal to 0. You know that this is the, for example, this is the universe. Inside the universe, reaction is going on. This is the entropy of its system. This is surrounding, and if this is universe, so we can say that if a reaction increases the entropy, if the reaction increases, the entropy of the universe increases. If a reaction increases, entropy of the universe increases. And the reaction would be spontaneous. So we can write this whole system like this, that entropy, standard entropy total is equal to surrounding plus entropy, standard entropy of the system. So this is the relationship of the universe, of the entropy with the universe. So if delta S total is positive, so the total entropy of the universe increases and reaction is spontaneous. But if the delta S is negative, total delta S is negative, the total entropy of the universe decreases and the reaction is non-spontaneous. Is it clear? So I will write down, if delta S total is positive, the total entropy entropy verse increases and reaction is spontaneous. On the other hand, is negative. The total entropy of the universe decreases and reaction is non-spontaneous. And we know that this is the, if this is delta S total for another example, this is delta S surrounding plus delta S and we know that delta S system is entropy of the system is equal to sum of product minus delta S reactant. And we also interlink with the enthalpy change. If enthalpy change is negative, delta H is negative, then negative entropy of the system would be positive or increased. But if the delta H enthalpy change of the reaction is positive, delta S would be negative. It means it is decreased. Entropy of the system is decreased. In other words, we can say if the reaction is exothermic, entropy of the system is increased or entropy of the system is positive. If the reaction is endothermic, entropy of the system is decreased and it is negative or reaction is endothermic. So we know that delta S surrounding is equal to minus delta H of reaction with the passage of time. This is delta H S surrounding, and we know that delta H enthalpy change of reaction, the unit of enthalpy change of reaction is kilojoule mole inverse 1. While unit of entropy, standard entropy change is joule mole inverse 1 Kelvin inverse 1. So we using this relationship, this is two, let's say this is two chemical equation and this is one chemical equation, we put in the main chemical equation delta S total. So delta S entropy of the total standard entropy is equal to delta H surrounding, the value of delta H surrounding is minus delta H divided by T plus delta S entropy of the system or reaction, you can say. So by multiplying both sides of the equation with minus T temperature, we get minus T delta S total is equal to into T minus T. So minus, this is equal to minus T delta S is equal to delta H minus T delta S. Whereas T delta S is equal to delta G and delta G is equal to delta H minus T delta S. So as a result of this relationship, sign of standard and Gibbs free energy provides information on the spontaneity of the given reaction, whether reaction is visible or not. Provides information on the spontaneity of given reaction. If delta G is less than 0, the reaction is non-spontaneous. The reaction will be non-spontaneous. If the delta G is more than 0, the reaction will be non-spontaneous. Less than 0 less than 0, it will be spontaneous. Reaction will be spontaneous or visible. If delta G is equal to 0, the reaction is in state of equilibrium. Hopefully you will understand the entropy, the relationship between entropy and Gibbs free energy, and Gibbs free energy and standard Gibbs free energy. Let us solve some reactions, some examples. Question is, given the data below, calculate for the following reaction. At 298 Kelvin and state whether the reaction is feasible or not feasible. If delta H is of the reaction, this is the chemical reaction. First write down the chemical reaction. C2H4 plus H2 to form ethane. So delta H of reaction is equal to minus 137 kilojoule mole inverse 1. Delta S is equal to minus 55.3 kilojoule. The unit of entropy is joule Kelvin inverse 1 mole inverse 1. So by using the relationship of Gibbs free energy is equal to delta H minus T delta S. So this is equal to minus 137 kilojoule mole inverse 1 minus 298 55.3 joules Kelvin inverse mole inverse 1 divided by 1000, because delta H is in kilojoule mole, so we for equalizing the units of delta S divided by 1000. So this is equal to minus 137 minus 16.4794. So minus 137 plus 16.4794. So this is equal to delta G is equal to minus 120.5 kilojoule. So if the delta G is Gibbs free energy is negative, the reaction is feasible. Is negative, the reaction is spontaneous or feasible. So this is how to calculate the any entropy change or temperature or Gibbs free energy by using this relationship. This is another question, this is another example. Calculate the entropy change of the surrounding for the reaction. So this is the chemical reaction, calcium plus oxygen to form calcium oxide. Solid, this is gas, and delta H reaction is equal to minus 1270.2 kilojoule mole inverse 1. So first convert, in first step we must convert delta H into joules. So convert enthalpy change into joules mole inverse 1. So this is minus 1270.2 into 1000. This is equal to joule mole inverse 1. Now apply the relationship. We use delta S surrounding is equal to minus delta H, the reaction, divided by temperature. So by using minus thousand divided by 298, so this is equal to plus 4262.4 joule Kelvin inverse 1 mole inverse 1. So this is how to calculate entropy of the surrounding. So there is another question. Calculate the total entropy change for the reaction. For example, if we're using the same reaction, calcium solid plus oxygen to form calcium oxide. Delta S, if delta S system is provided, joule Kelvin inverse 1 mole inverse 1. Delta S surrounding is also providing, is equal to plus 426.2.4 kilo in Kelvin inverse 1 joule Kelvin inverse 1 mole inverse 1. So delta S total will be, total entropy will be equal to, we know that delta S system plus delta S entropy of the surrounding. So this is 208.4 plus 0.4. This is equal to plus 0.4. So in this way we calculate the delta entropy, total entropy of the universe. Hopefully you understand the calculation as well as relationship between Gibbs free energy and entropy.